And welcome back. As we go ahead and continue our journey working through loops, let's take a moment to go ahead and address a couple looping errors that you might encounter. So the first thing we have to address is the pitfalls of using loops. We've already talked about the pitfall of placing a semicolon at the end of a for loop statement. It causes, of course, the loop to skip the body loop and proceed to the next line of code. Now, generally we want to avoid using a semicolon to end our loop statement and just stick to using our curly brackets to really kind of encapsulate the loop body. Now, the other thing that we might run into, which is actually a much more common issue, which is the infinite loop. All right, these can happen with any type of loop, so whether it's a for loop, a while loop, a do while loop. What happens here, if we look at this example, we say number equals 1, while number is not 12. I'm going to say this is an output line number, so we're just outputting number, and you can see we have number equals number plus 2, so we have a increment statement. However, if this program wants to leave this loop, it has to, of course, be equal to 12 because it says while number is not equal to 12. So as long as it's not equal to 12, it's going to loop through here. And you can see because we're starting at 1 and we're adding 2, it's always going to be an odd number, so it'll never hit this value that we're looking for. In fact, this program is going to just keep on running until the system pretty much runs out of memory. It'll just crash effectively. So how can we overcome these pitfalls? Well, the easiest way of dealing with the infinite loop, of course, is to avoid creating situations that might produce one. Loop conditions that use either equals equals or not equals are the most common ways of doing this. So when we start looking at loops, very rarely are we going to have something that's going to have that explicit type of comparison. It's much safer to test either a less than or greater than, or less than equal to or greater than equal to, because again, you're looking at a range rather than a specific value. This allows us to initialize the variable to any number, and the loop will still terminate. Though I do want to stress it's important to make sure we test for a variety of values, as some of those values might still cause infinite loops while others do not, especially if you start doing any kind of, let's say, arithmetic operations to a variable that might change the variable depending upon certain actions in your program. So it's very important that we make sure we test for those wide variety of cases. Now, one thing I do want to stress, though, is that not all infinite loops are necessarily by their nature bad. Just because it's an infinite loop doesn't mean it's a bad thing. Some programs are actually designed to have infinite loops in mind. These programs are designed to run infinitely until the computer is either shut down or the program itself has been terminated. We can purposely create an infinite loop, for example, in a while loop by using the following expression: while true. All right. It's always going to be true unless we have something that's going to force it out. And notice there's no inequality, for example, in here, or an equal statement. This one is always going to be true, so just while true. Because that evaluation is true, the loop is always going to run until something forces that loop to exit. This is something we saw when we looked at our continuous input program, and we had to break out of that loop. So in this case, though, that's good because we want that program to keep getting input until we're done. Now, there are some other errors that might occur with loops. One of the things you have to understand with some of these other errors that are going to happen, though, these are what are known more as a logical type error rather than something that has to involve with syntax. And we are going to take some time to actually look at some troubleshooting techniques. So we're actually going to hold off on how to address and resolve these type of errors when we take that deeper dive looking how can we troubleshoot code, making sure we're getting the values that we want. So for now, the biggest thing is just be mindful of our semicolon placement and to be careful of those infinite loops unless it's a situation that actually calls for it. And here it is an example code to show you what code might look like if we have these type of errors. So here I have a semicolon misplacement, and you can see in here I have just a while loop with a semicolon. There's no curly brackets. So I'm just going to go ahead and run this code right now. And you'll notice it just has a blank screen down here. In other words, it's hitting this, but nothing's happening. We're not getting any print statement. We're not getting anything else going on. It's simply just hung up here. And so even if I go ahead and try, well, I'm going to go put some curly brackets around this, and that should resolve it. Well, one of the things that's going to happen, even with those curly brackets in there, you can see nothing is still happening. So again, something you have to be mindful of if we start putting semicolons in places they don't belong. It's always better when we're dealing with loops simply to be explicit with using curly brackets, especially if you're just starting programming, to avoid any kind of weird behaviors such as the following. Now, if I of course, take that curly bracket out there, and I go ahead and run this code now, and you can see now we have our printed message, and it has worked beautifully. Now I'm just going to go ahead and temporarily take this out of here just so you can see the infinite loop example. And this one says while num is not 1. So we're starting num at minus 10, so that should work here. And so it's going to say help, I'm trapped in infinite loop. And notice we're decrementing here. All right, which means we're looking for this to keep getting smaller. So if I go ahead and run this program, you can see my code still keeps going and going and going. In fact, I had to actually stop my program to actually get it to stop giving me these messages about being trapped in an infinite loop. So again, both of these are ways for us to kind of look at our code to kind of see these different types of errors. These are things that are very easy to avoid. For example, this one we fixed real quickly by simply taking that semicolon out of there. If we have an infinite loop like this, the way we could address this one is we can either change the expression that we have here, or if we know we have a value that can be modified here that we're comparing to, we can do that. Of course, I would always address first is this, the expression itself, because that, of course, could be something that may be the actual root cause of the issue. So, for example, if I go ahead and say, you know what, we know that this is going to be decrementing. We want this to be saying, well, it's not equal to 1. We know that we say it's greater than 1, it won't work. But if we say that it's less than 1, obviously, even with this one, I want to point out, I'll just grab this real quick. It says, while num1 is less than 1, if I go ahead and run this, we'll still get an infinite loop. But that gives me a lot more to work with that can then address what my other values are. And we'll talk about this more when we get to troubleshooting. But it's, again, something to watch out for, because even you can see it doesn't necessarily explicitly happen with equals equals. However, it's easier to fix when we don't have an equals equals or a not equals in here, because this is a lot easier to address with an inequality than it would be with an explicit value.